For most of us, a stroll on a desolate beach means wind, waves, driftwood, and the odd plastic bottle. But probably not one of these. For the last 20 years, maverick Dutch artist Theo Jansen has been building these remarkable vehicles, or beach beasts, in his shed.
I came up with this idea of making skeletons on the beach to build dunes to save us from the rise of the sea level.
But Theo's original idea for automated sand-shoveling vehicles soon morphed into something far more interesting, a new species of artificial life forms powered by nothing more than the wind. He christened them Strand Beasts.
A big advantage of the Strand Beasts is that they don't have to eat. They wait for the wind, and they use the wind as their energy source.
To bring his machine to life, he first needed a material that was cheap, strong, and most importantly, light.
This kind of tube we use in Holland for power lines in houses, so it's everywhere on the street. It has the color of cheese. The kids in Holland, all they know this tube because they blow paper dots in open windows.
To an engineer, these are just plastic tubes. To Theo, they're his invention's basic building blocks.
These are the cells of the Strand Beast. The special thing about it is that on each side they have a sort of cave which fits exactly on another tube. If you connect this, then you can make a structure.
Aristotle once said, there was never a genius without a tincture of madness. And he might have been talking about Theo and his beach beasts. Theo's love of theatre and his passion for artificial intelligence led him to try and develop vehicles that can move by themselves. But how? Simulating the fluid movement of the human stride is a problem that has outfoxed many an inventor for years.
When I started this, I didn't know how to move the thing. So I had rolling kind of animals who just move by gliding on the wind. And then I came up with this idea of legs. Legs seem so simple. I mean, to walk on the beach, that's what you want.
Theo got to work. If the vehicle was to move, it would require long legs, which could stride, a body that remained stable, and feet that wouldn't sink in the sand. But incorporating all these features into a single unit or limb was easier said than done.
And when I started this, I didn't know which combination of length I needed to get this leg. That's why I wrote this computer program. I needed 13 length to generate this kind of leg. The body of the beast stays on the same level, and the feet just walk under it.
But despite the brilliance of Dr. Theo's design, it had one potential major flaw. If the wind disappeared, the beast would indeed be stranded. Over to you, Theo.
The wings on top, they pump air into lemonade bottles to high pressure. I call this the wind stomach. And they can use this energy to survive the wind silences on the beach.
A wind stomach is simply a soda bottle full of compressed air, which can provide the continuous power the beasts need.
Here we have a wind stomach, so it's full of air now, full of pressed air, and we can use that energy for all kinds of things. For instance, feeding this network of nerve cells.
These cells, or valves, switch on and off, triggering the pistons that power the legs.
This works just like switches. And you could compare this with electronic switches. You can do anything with electronics. You can also do with air.
In fact, this on-off switching mechanism is a bit like binary code. In a way, Theo has created a primitive computer.
So in fact, what you see here is the beginning of the brain of the beach animals, because with this you can build binary counters, so they can count their steps on the beach, so they know where they are more or less. You can also build time mechanisms which run parallel to the tides, so they know in advance when the tide will come up and they can anticipate on that situation.
And no sooner had Theo overcome the key mechanical problems than his fantastical imagination ran riot. But what if Theo's self-animating creatures wander towards danger? The sea, for example. Could his wind-powered valve system be used to save them?
What we see here is a water feeler, and this tube, it goes over the ground about this height, and it sucks in air all the time. And as soon as it arrives into the sea, it swallows the water and feels the resistance of the water. And then a switch goes over, and then the animal knows it is in the sea and should do something. Now, I connected with the bottles to give it energy, and now it starts sucking. It goes into the water. You should hear the nerve cells running. As soon as they felt the water, they should run out of the sea again.
Theo's dream of creating a new form of artificial intelligence would appear to be close to becoming reality. Who needs cloning when you have plastic tubes and a shed on the beach?